Okay, hi everybody. Let's draw back in. So let's get kicked off with this session where we'll talk about networking and a really high level for a topic where I've had to learn a lot as a software engineer that doesn't know much about engineering from a sort of IT perspective. So I know enough to be dangerous in Azure when it comes to creating networks and how I would typically go about doing things. But I will deliberately skirt around the areas that I don't know much around. So what I will say, I've got all of the stuff that I've been through twice now, but for those who haven't, this is basically the content to get you going with a repo, which hopefully you can actually join along with and actually create some stuff. Idea of this being as much of an interactive session as possible, so I will skip over the content that I've already been through and go straight into networking as best as I understand it to this point. Okay, so networks. So if you are creating resources on the internet, there are a whole bunch of IP ranges that you could get assigned. Your address for your resource would be a standard IP address. You'll all be familiar as engineers what an IP address is, hopefully. Private networks that exist within a cloud estate that you might create need to sit within certain accepted private IP ranges. So you can't go ahead and provision a network, well you shouldn't, that sits outside of private IP ranges, because guess what, you could accidentally hit on someone's random public IP address at some point and cause yourself all kinds of grief. So for that reason, there are known and agreed upon IP ranges that are reserved for private use within a network. So no one is allowed to use them publicly. An ISP can't assign your home router to 10.0.0.0 because that would cause a lot of problems for a lot of people. So there are enormous ranges of values that can be attributed to private networks. So you can have really quite extensive ones, and they are fundamentally in three different areas. So these sit within different, what's technically referred to as classes, as I understand. So the third and final class is what you typically find in your home broadband kind of local networks, the 192.168.0.0, unless you're sysadmin over here sort of assigning all the things to your local router equipment or various things like that. Typically people have 192.168.0. something as their router, and whatever else falls on automatically assigned by DHCP by your router when you connect over Wi-Fi to your home broadband. Okay, so that is broadly what a private network should exist of. A private IP network is going to be a network of interconnected resources that use IP addresses in the private IP range. So when you're creating resources in Azure, you might not necessarily assign a private address. Like in the previous session, we created an Azure web app, or we tried to create an Azure web app. That would not necessarily be connected to a virtual network. But if you wanted to start tying down from a security perspective, access to back-end resources like databases and things like that, you are going to very quickly need to know things to do with networking and how to actually obscure those into a back-end private network that only resources that should be able to access them can do that. So how do you actually go about segregating things? Well, that's usually done with what's called a subnet. So I think in the initial session, we had a sort of stretch goal for those who got far enough along to create a virtual network, which just had a broad IP range of /16 CIDR. Now, all of this goes quickly into quite sort of maths that you might not have touched in quite some time, but we're all talking about bytes. And subnet masks are all represented in bytes, and essentially it's all to do with 2 to the power of something, which will represent the number of IP addresses that are available on a particular, what's called a CIDR range. So I've jumped ahead a little bit, but essentially what is a subnet? It's a subsection of IPs within your total range of your network that are dedicated and isolated for a particular purpose. So typical pattern is you might end up with a web subnet, which is like your front end one that has resources like your web apps on it that might be accessible by a front end IP that's a public IP that would be assigned a random internet one that you can actually access outside of the network. But then you might end up having a data subnet, for instance, for an example where you have a database, and that database should not be accessible by anything except known allowed data routes. Now, how do you do that? Well, you essentially have to create explicit connections between subnets for them to be able to. So imagine they're sort of isolated buckets of resources in their own ranges. You have to do something that's called peering to be able to connect two subnets together so that they can talk. So what you do in this example would be you'd peer the web subnet with the data subnet, which would mean over private IPs, it can access the web subnet in its back end, can access the database resources over a private IP. Now, I'm not going to go into the details of exactly how you go about doing that in this session because there's quite a lot involved to do with private DNS zones. You can use things like private link within Azure, which enables the connection of a whole different type of service, say Azure SQL Server, over private link into a network. You need to be on certain types of tiers, premium, to be able to do a lot of this where it's connected to private networks. And that's certainly not something we're going to be standing up today because that costs a fair whack for everyone to stand up premium tier app services that can connect to virtual networks and databases. So what we will do though is we'll aim to create a virtual network, create a couple of subnets on it and peer those subnets. And we'll leave it there. And then everything else is for future reading. Some very, very high level common network designs. So you will refer to hub, you may hear of the term hub and spoke network before. Essentially the star network is another way of saying the same thing as I understand it, where you have a central switch and then multiple sort of switches off of that. As far as the Azure resources are concerned, imagine that switch is like your subnet and Azure will handle what sits on each IP within that subnet itself. So you don't necessarily get access to switches and all that kind of stuff, but conceptually that's what we're dealing with. So hub and spoke is by far the most common pattern when it comes to deploying applications in the cloud in terms of developing a cloud network. It's typically used there. We'll not go into VPNs and translating between different IP ranges. That was a headache that Matt had to deal with on the AI Center project, which was all kinds of fun. But other types of networks that you might have heard of is the notion of mesh. So mesh is where you have every device on the network is connected to each other, and then you've got a partial mesh here at the bottom where you've got essentially a strand off it where like a printer in this example is hardwired into a laptop and is not technically able to be accessed by every other device on the network. Essentially that's how that works. And this is where we get into the bit that's a little trickier to understand. So CIDR notation, which is where I got to before. So this is what we would refer to as an IP address here, but then the CIDR notation bit is the bit here on the end after the slash. So 24 represents the number of bits that are allocated to the IP address. Fundamentally, the bigger the number, the less IP addresses there are available. So if you have a /16, which I think I used as the example for creating the virtual network in the first session, that is a pretty chunky network where you can assign, hundreds of IP addresses.
32,000.
Yes.
5,500.
Yes, something like that.
Far off.
Apply, yeah. Sorry, I think I intended to say apply. So yeah, please apply that, and then for the sake of recording, Jake's asking about the setting himself up. No, it's fine. So there's a bunch of calculations you can do in terms of number of IP addresses. 24 is a reasonable range for a standard subnet. 32 goes all the way up to 32 because 32, when you calculate it, results to 1. So if it's /32, it just means this IP address and this IP address alone. Yes. You can read into the calculations. There are CIDR notation calculators out there, Google it, which will give you if you put in this IP address /24, what range does that mean? Now, the example that we've got here for /24 is eventually it calculates out as 2 to the power of 8, which is 256 IP addresses, but because they are zero-based, that actually results from 192.168.1.0 all the way to 255. So if you're thinking conceptually, okay, how many IP addresses, if you've got /24 in your subnet, hint for later, that would be a reasonable CIDR choice for a subnet, and you might want 192.168.1, 0.0/24, and then you might want 0.2/24.
So you already said how many /24 gives you?
Yeah, 256 IP addresses ranging from 0 through to 255 if you do 1.0. That makes sense here. I'm pointing the wrong bit here. So that's what /24 relates to. Okay, so the challenge, so this is a shorter session which will hopefully allow people to play catch up with some of the stuff that you might have been doing in the second session, is to look at the Azure RM provider documentation. Now actually I've sent links to this already in the Slack channel for other resource types, but hopefully you should be able to find a virtual network within there. And if you haven't already, with the first session, where the bonus task was to create a network having established a remote state file and just as your first block, create a remote network, try and do that right now. And then what you can do it in two different ways. So Adam, for instance, I saw that you actually had subnet blocks within the network block. That is a valid way of doing things. However, it's slightly more flexible, in my opinion, if you actually do separate resource blocks for subnets. So you will find in the Azure RM provider documentation something like virtual network, subnet, or something like that adjacent to the virtual network in the documentation. So if you find that resource block type, you can associate that with the virtual network. So rather than having to change your virtual network block every time you want to add a subnet, you can just add another subnet block that references it. That is a slightly different way. And
the ability to, if you've got separate teams with their own Terraform, then they can manage their own subnet.
Yeah. So if there's if, for instance, they don't necessarily have full control over other subnets and they just want to add a subnet to an existing virtual network, they can stand up a data resource that says, for this existing virtual network, I need to create a subnet, and they might be told by someone else, you're allowed IP ranges X and Y, or aside a subnet of /24 on whatever IP address, and then the final challenge for this session will be to peer the two subnets. Now, hint with Azure, when you're peering, you need to go in both directions. So you will need two resource blocks, one that's a peer from the one subnet side and one that is peering from the other subnet side. connects, say, bidirectionally in that way. I don't think technically you have to do that, but I've always done it. Okay, so we're nearly at time, so I guess we can close out the session here. What I would say is that I'm just going to drop the slides from this third and final session on OpenTofu as a PDF into the Slack channel, so look out for that imminently. But if you've got any questions or follow-up, or you want to have a bit more of a play, what I'll do is I'll leave the resources up, but try not to create anything particularly expensive whilst you're messing around with it. Incidentally, if you wanted to look at it, it's quite cool. There's something called Infracost, which Matt actually introduced me to on the previous projects that we worked on together, which Infracost will actually look at a Terraform or Tofu plan and basically calculate the costs for your infrastructure. So sometimes if you create that in a CI/CD pipeline and you have a pull request and it goes, someone's changed that app service from F1 to P1 V2 or whatever the premium thing is, and it jumps up from nothing to 100 quid a month or whatever, then you can spot that in the pipelines before things get merged in and Terraform plans or Tofu plans get applied. So that's a really useful thing to look into. I'll drop a link to Infracost in the Slack channel. So that's a free resource. I think you just sign up for an account and then create some kind of API key, and then you can embed it in your CI/CD pipelines, and that's really useful. I haven't had a reason to pay for it yet, but I don't know. Until it starts erroring and saying you need to pay, I will not, because it does its job. It's really neat as well. It actually, if you give it the right perms, it will inject comments into the actual PR within GitHub. So you'll see a block with Infracost findings and a diff, basically, current expected costs, i.e. the plan previously versus the plan afterwards. And here's a difference in cost. And that's actually quite useful for someone who's going approve or not. Worth a look. But thanks for coming along to this. As I said, I'll put the slides in here. If you've got any questions, there's actually, if I bring that slide up, that would be helpful. What I would say is there is a... One second. There's a Slack group which... aside from the OpenTofu sessions, one that we've been having links for today, there is a somewhat dormant group, DevSecOps, but by all means, if you will jump into that one, and if you've got any questions, those who have used Terraform and OpenTofu before, hang out in there, and someone I'm sure will be able to help you if you've got any issues with anything you're doing with OpenTofu or Terraform in the future. Thanks a lot. And we'll catch you at the social.
Thank you.